There is a real planet where the sky may rain liquid metal sideways. A world so close to its star that gravity is stretching it toward destruction. Its name is WASP-121b. It orbits its star in about 30.5 hours at a distance of roughly 0.025 astronomical units. That is so close that this planet is not just hot, it is being chemically dismantled, meteorologically brutalized, and physically pulled toward the edge of survival. And what fascinates me is that WASP-121b is not merely bizarre, it may be one of the clearest natural experiments in how a planet dies slowly before it is finally torn apart. This is the what. WASP-121b is an ultra-hot Jupiter, a gas giant bigger than Jupiter, but orbiting absurdly close to its star. The how is where the nightmare begins. Extreme starlight superheats one side. Violent winds redistribute that energy. Metals vaporize high in the atmosphere. And the whole planet is so tidally stressed that it is nearing the Roche limit, the boundary where gravity can rip a world apart. And the why now is simple. In the last few years, instruments like Hubble, spectrographs such as ESPRESSO, and new atmospheric modeling have turned this planet from a curiosity into a mapped crime scene. We are no longer guessing that its weather is extreme. We are tracing it. Start with the most famous detail. In 2020, a study led by Jens Hoymakers and collaborators using the ESPRESSO instrument on the Very Large Telescope found at least 7 metals in the atmosphere on the day side of WASP-121b, including iron, chromium, vanadium, calcium, sodium, magnesium, and nickel. Not buried in rock, not locked in a core, in the atmosphere itself. Vaporized, floating in air heated to around 2,500 to 3,000 degrees Celsius. Try to picture that for a second. On Earth, iron means bridges, blood, train tracks, frying pans. On this planet, iron can become weather. Not metaphorically, physically. But there is an important correction here. Scientists have not literally watched droplets of iron hit the ground. What they have observed is strong evidence that metals are vaporized on the scorching day side and can condense as they move to cooler regions. So when people say WASP-121b has iron rain, the deeper truth is even more disturbing. This atmosphere is hot enough to turn familiar matter into a planetary-scale circulation system of metal vapor and condensation. The winds make it worse. In 2021, research using high-resolution spectroscopy reported that material in the atmosphere moves with enormous speeds, on the order of several kilometers per second. Some measurements suggest powerful jets carrying vaporized elements from the day side toward the night side. On Earth, a hurricane terrifies us at a few hundred kilometers per hour. On WASP-121b, the weather can move faster than a rifle bullet for thousands of kilometers. And because the planet is tidally locked, one side faces the star almost permanently. One hemisphere is blasted non-stop. The other is relatively cooler, though cooler here is still hellish by human standards. That permanent imbalance creates a machine. Heat rises, gases expand, winds accelerate, atoms get ionized, chemistry shifts, and the atmosphere becomes less like weather as we know it, and more like a wound trying to close while being forced open. I'll be honest, this is the point where the planet stops feeling like a place and starts feeling like an event. Then, astronomers found water molecules in the atmosphere, and even stranger, signs of a stratosphere. In 2017, Thomas Evans and colleagues using Hubble observations reported evidence that water and vanadium oxide were linked to a temperature inversion high in the atmosphere. That means the upper layers can get hotter as you go up, somewhat like Earth's stratosphere, but driven by a wildly different furnace. The atmosphere is not only hot, it is vertically structured in a way that tells us radiation is being absorbed and redistributed with incredible efficiency. Miniature clue after miniature clue, the same picture keeps emerging. This is not a stable giant planet with quirky weather. It is a giant world living inside conditions that are actively unmaking it. And the most dangerous detail is not the iron. It is the orbit. WASP-121b sits so close to its star that it is near its Roche limit, the critical distance where tidal forces from the star can overpower the planet's own gravity. Imagine holding a water balloon too close to an industrial fan. At first, it just deforms. Then it stretches. Then one more push, and the shape stops being recoverable. That is the cosmic version of what may be happening here. In 2019, observations suggested that heavy elements, such as magnesium and iron, were escaping from the planet's upper atmosphere. Other studies have also pointed to atmospheric loss and an extended envelope of material. So this is not just a planet being heated, it may be shedding itself into space.
If you had to choose, which is more terrifying? A planet with oceans of lava below you? Or a sky above you filled with vaporized metal and supersonic winds? Tell me in the comments before we go deeper, because the answer gets less obvious the more you look at this world. There is also something almost tragic about how precise the destruction is. Too far from the star, and WASP-121b would just be another gas giant. A little closer, and it might already be gone. It exists inside a narrow corridor where we can watch the process of ruin without missing the planet entirely. That matters, because exoplanets like this force astronomy to answer a brutal question. How much punishment can a world absorb before it stops being a world and becomes debris? You can hear the philosophical edge there. I think that is why this planet stays with people. It turns orbit into mortality. By now, astronomers have gone beyond simply detecting a bloated, hot Jupiter. They are reconstructing atmospheric circulation. In 2024, analyses with improved phase curve interpretation and high-resolution follow-up kept refining how heat is transported between hemispheres and how dissociation and recombination of molecules may affect the energy budget. In plain English, even hydrogen chemistry may help move heat around this planet, making the weather system more violent and more efficient than older models suggested. And that changes the story. This is not just a weird furnace under a star. It is a dynamic engine where radiation, chemistry, and gravity are all pushing against one another in real time. But wait, there is a twist that almost nobody mentions. The real nightmare is not that WASP-121b is extreme. The real nightmare is that it may be temporarily extreme. What if we are catching it during a short-lived phase? What if this is the brief interval between being a swollen gas giant and becoming something far smaller after losing huge amounts of atmosphere? Suddenly, the story is not, look at this bizarre planet. It becomes, we may be witnessing one frame in a planetary execution.
That idea connects WASP-121b to a much larger mystery in exoplanet science. Why some close-in planets survive, while others are stripped down into smaller remnants. There is evidence across many systems that intense stellar radiation can erode atmospheres over time. WASP-121b sits near the extreme end of that process, like a stress test built by nature. Personally, I find that more unsettling than the molten metal headline. Iron rain is cinematic. Atmospheric ruin is existential. Because once you see it this way, this planet is not an outlier. It is a warning label attached to planetary physics. Whispering, think about what that means. A planet can be too close to safety to escape, but not close enough to die quickly. It can spend ages being stretched, heated, chemically scrambled, and slowly peeled apart. And if you're wondering whether there could be anything solid to stand on beneath all this, probably not in any human sense. WASP-121b is a gas giant, likely bloated by intense heating, with no conventional surface. So even the fantasy of surviving the sky fails. There may be no ground to meet you, only deeper layers of pressure, heat, and collapse. If the fact that a planet can be turned into a long, slow experiment in destruction surprised you as much as it surprised me, leave a like. Not for the spectacle, but because worlds like this deserve to be remembered as more than odd trivia. So, what is the payoff? Why should anyone care about one doomed gas giant 850 light-years away in the constellation Puppis? Because WASP-121b reveals something uncomfortable about the universe. Planets are not permanent achievements. They are negotiations between gravity and heat, between orbit and radiation, between structure and erosion. On Earth, we take stability for granted because our planet sits in a rare balance that feels normal from the inside. But normal is a local illusion. Out there, the cosmos is full of places where a world can become weather, where the atmosphere can become an escape plume, and where being a planet is less an identity than a temporary condition. I think that is the real reason WASP-121b matters. It shows us the borderland between planet and catastrophe. Not in theory, in data, in spectra, in measured winds and detected metals and escaping atoms. And there is something humbling in that. We usually imagine discovery as a way to make the universe feel more knowable. Sometimes it does the opposite. Sometimes the closer we look, the more reality resembles a nightmare that happens to obey equations. WASP-121b may be the closest real planet we have found to a cosmic nightmare. Not because it breaks physics, but because it obeys physics so completely that the result feels monstrous. Liquid metal skies, supersonic winds, a stretched atmosphere bleeding into space. A whole world balanced just above the line where worlds come apart. And somewhere in that violence is the strange beauty of astronomy. It does not only show us where life might flourish, it also shows us how creation fails, how planets unravel, and how thin the margin can be between a world and its destruction. If worlds like this expand your sense of what the universe can do, subscribe and stay with this channel. We chase the places that make humanity feel small, fascinated, and just a little unsettled.